Okay guys, welcome to lesson 8.7, functions defined by equations. Now you know that we have already started talking about functions. So this is 8.7, functions defined by equations. So let's review. What is a function? You remember, a function is a correspondence, or we called it a match, or we could also call it a relationship. It's a kind of relationship between two sets. And the sets could be numbers, they could be trees, they could be whatever, really. Mostly we're dealing with numbers. That's better. Sorry, I was a little unfocused. Okay, so between two sets, and the two sets have names. The first one is the domain, and the second one is the range. And we saw that you can show a function with a graph or a chart, but now we want to know is, what about an equation? Can we show the relationship between two sets using an equation? And of course the answer is yes. Oh, I almost forgot. This isn't just any relationship between two sets, the domain and the range. A function has only one range member matched up with the domain. In other words, each member of the domain only has one member of the range assigned to it. So for example, if I gave you a list of people and birthdays, so a list of people is the domain and the birthdays are the range, you can't have one person with multiple birthdays. That would not be a function. It would be a relationship between them. You could imagine like some sci-fi scenario where this guy was born 3 different days, like CJ, your doppelganger, you know what I'm talking about? So you could have somebody born on 3 different days, but that would not be a function. That would just be a different kind of relationship. So a function has one member of the range assigned to the domain. You can reuse the same. You can have multiple people born on the same birthday, but you can't have one person with multiple birthdays, if that makes sense. Okay, I hope I didn't confuse you more. But the question is, can we shift showing the relationship, showing the function from charts and tables and graphs into an equation? And I said yes. So let's set up a situation and see what that does. Suppose you're selling tickets that cost $5 each. Okay, and then to a show that you made. And the show cost $500 to make. Okay, how much money will the company make? How much profit? Now, how much profit will they make? And the answer is, it depends. What does it depend on? It depends on how many tickets, right? So if we sell no tickets, how much money do we make? We actually lost $500. If we sell 1 ticket, how much money would we make? Well, I say make, but you see where I'm going with this. We'd actually lose $495. 2 tickets, we would lose a little less. Can you imagine how many tickets do we need to sell? Can you just do the mental math to figure out how many we need to sell to break even? We would make $0 if we sold 100 tickets. Now, if you finally sell 101, we made $5 on our show. So let's think about this, and this is a relationship between these two sets of numbers. We're going to call this N. That's the domain. It's the number of tickets sold. And we're going to call this P. That's profit, how much money we make out of this thing. So can I can I make an equation that shows the relationship between these two numbers, that shows the function relationship? And the answer is yes, right? So the profit is always going to be $500. Oh, excuse me. The profit's going to always be $5 for every ticket sold, minus the money it cost us to make the show. So the profit's whatever is left after we take the $500 away from ticket sales. That's our equation, and that shows us a function. Okay? Now, there's more than one way to show this thing. So let me explain. This is fine. It shows profit depending on the number of tickets sold. But then we have something called arrow notation, and I want to explain that to you. Arrow notation looks like this. I'm going to take this and put it in arrow notation. So profit matches to n. So profit has a relationship with n like this. So profit matches with n by taking n times 5 and subtracting 500. Do you see how they're doing that? This shows you which two things match up, and this shows you how they match up. Okay, there's another way. That's called arrow notation. The second way is called function notation. And these all mean the same thing. This means the same thing as this, and means the same thing as what I'm about to show you. This means profit depends on how many tickets you sell. So P depends on M like this. Okay? So what this is saying is, people will read it like this. P of N equals 5N minus 500. That just means that profit depends on the number of tickets sold like this. So we've got three different ways to show this equation. Regular old equal sign way, arrow notation, and function notation. You're going to have to be able to work with both or all three ways. And let's do a couple examples of what you'll need to do, and I think it'll make more sense. Okay, so I'm pulling these examples straight from the book, so you shouldn't have any trouble following along with me. The first one says this. If I have G matched up with X, so G depends on X like this. 4 plus 3X minus X squared. And it says list the range of this if the domain is equal to -1, 0, 1, and 2. Okay, now the domain is everything that the X can be. So all I'm going to do is take each of these numbers and plug it in, just like this. So when D is -1, or 0, 1, or 2, then what's the range going to be? Let's just make us a little one of these guys. Okay, so I'm going to plug in -1. So 4 plus 3 times -1 minus -1 squared. 4 minus 3, -1 times -1 is 1. So 4 minus 3 is 1, 1 minus 1, so 0. Okay, let's plug in 0. 4 plus 3 times 0 minus 0 squared. That's 4. So what I'm doing is I'm taking each one of the domain numbers and I'm taking it and plugging it in wherever there's an X to give me what G would be if X is this number. So this is the value of G when X is this. 4 is the value of G when X is 0. Now you try to find the value of G when X is 1. And I think you know what to do. You plug 1 in. 4 plus 3 times 1 minus 1 squared. 4 plus 3 minus 1. 6. Now let's do 2. 4 plus 3 times 2 minus 2 squared. 4 plus 6 minus 4 is 6 again. So notice the problem said to list the range. So all we need to do here is go R equals squiggle line, or it's called a brace. 0, 4. Now notice 6 is listed twice, but we only need to list it once because it's just the range. So this is the answer. The range is 0, 4, 6. If the domain is negative 1, 0, 1, or 2. Okay, let's do another one. Suppose we've got this function here. We've got the function called f, which is mapped on with x, and we're using arrow notation, x squared minus 2x. Okay? Now let's write it in function notation too, just for practice. F of x, whoops, f of x equals x squared minus 2x. Now it says find f of 4. Now what does this mean? This means that there's a function called f that takes x and does this to it, to match it. So all we need to do when you see f of 4 is you plug 4 in where x is. And then that'll tell us what f is, the value of f when x is 4. So f of 4 is equal to 16 minus 8, which is 8. Let's do another one. What would f of negative 3 be? F of negative 3 means we want to know the value of f when x is negative 3. So negative 3 squared minus 2 times negative 3. 9 plus 6. So f of negative 3 equals 15. That's our answer. Now I'll leave you to try this one. What would f of 2 be? Well, you're going to plug in 2 wherever the x is. I'll wait just a second. F of 2. Did you get it? Okay, good job. All right, you guys, I think you're ready for the homework problems. So let me know if you have any questions.